Hi, and welcome to our first week in food cost accounting. We're going to just start off by going through some of our math basics in the culinary world. So let's get started. Our learning objectives this week are to familiarize ourselves with the units of measure. This includes all of the measuring equipment and the proper measuring techniques to use when using the equipment. We're going to distinguish between count, volume, fluid ounces, and weight, and really thoroughly understand the difference between weight and volume because we do see a lot of misconceptions here, especially when you're dealing with home recipes versus professional standardized recipes. We're also going to cover the metric system, including what it is, how to use it, and the advantages of doing so. And we will look at equivalencies between our metric and customary system and learn how to convert between those two. And finally, we will start learning how to convert between different units of measure, including how to do it. I will go over two different methods on how to do so. You can choose which one is best for you. And we're also going to discuss when converting between mixed measures and the rounding reality of doing so. So why do we measure? In this industry, we are producing, large scales of food. It's extremely important that we have accurate, weighed out recipes so we can consistently make the product that we want to sell. We rely on standardized equipment because it helps provide that consistency, but it also helps us measure things quickly and efficiently. So the less time you can spend doing something, but still make, a great amount of product, potentially the more money you will earn because you now have lowered labor costs. Ironically, though, about this standardized equipment is that we love it. We love it so much that the labels become worn off. So, this will be a visual activity that we do in class when I show the most common units of measure in a kitchen, and we will learn how to distinguish between them even when they are not labeled anymore because we can recognize them based off shape, size, and appearance. In the end, we are measuring for accuracy. Accuracy is the goal. We want to have consistent products because consistent products for customers means we are a reliable business. We have a reliable reputation, and potentially it could improve the food quality. So there is no, oh, it was better last week, or when so and so worked here, that's when it was good. We want to avoid those claims that customers often make when they can see changes in a business and don't really know why. We want to rely on standardized recipes, standardized equipment, and procedures, hopefully, good training along with that to ensure that no matter who touches a recipe, it can be done successfully and more or less accurately every single time. Also, measuring helps us control our food costs. So we are living on razor thin margins in this industry, trying to make a profit, battling every expense that the food industry business faces. And this is one area that helps us save pennies, those pennies that add up and make a difference in the end. So measuring does help us with labor costs, managing and accounting for any waste that we experience, and if there's the potential use of trim. So let's start with our common household measurements. Hopefully, you are all familiar with these, and hopefully, you have them at home and you know how to use them, but let's go over them just in case. So, our nested measuring cups are pictured on the bottom there. The most common sizes that I will refer to and only use in this class and from here on forever and ever are our 1/4 cup, our 1/3 cup, 1/2 cup, and 1 cup. Yes, you can buy more extensive sets. They'll have an actual 1/8 cup or they'll have an actual 3/4 cup, but really no purpose in doing so, especially with our 3/4 cup or our 2/3 cup. You can just use those singular cups twice or three times to get to the amount that you need. We don't need an actual cup that dictates that size. So, whenever you are working with recipes from here on out and you are trying to be as professional as possible, only use these four measuring cups ever. So these are used for dry and liquid ingredients, but just know that weight is always going to be more accurate. So this is a common method used in those home recipes, those home chef recipes, anything you find on the internet usually, is using these measuring cups to measure out dry ingredients. Now we're going to talk about this a little bit later because this is the difference of volume and weight, but we'll get back to that. So moving on, our graduated measuring cup that is pictured on the top there. The most common sizes you're going to see are 1 cup, 1 pint, which is 2 cups, 1 quart, which is 4 cups, and then 1 gallon, which is 16 cups. So these are definitely only supposed to measure liquid ingredients. So if you are ever asked to go get 1 cup of something, but it is a dry ingredient, go ahead, grab a nested measuring cup instead, and do not grab the graduated measuring cups. And then what the only thing that is not pictured, but hopefully again we're familiar with these, are our measuring spoons. And again, most common sizes in the industry professionally used: 1/4 teaspoon, 1/2 teaspoon, 1/3 teaspoon, and 1 tablespoon. So note that there is no 1/3 teaspoon. Okay. You might want to start, and when you start converting recipes, you might want to start labeling one thing, a teaspoon 1/3, but those are not a common size. You can find them again in those extended sets, but it is not commonly used. It is such a small difference between a 1/2 teaspoon and a 1 teaspoon that there really isn't from a 1/4 teaspoon to a 1/2 teaspoon to have the need for a 1/3 teaspoon. So these are just the 4 sizes of measuring spoons that we use. And we often see these used for dry and liquid ingredients. So for our measuring methods, we will practice this in class so we can see the difference. But when you are measuring volume, you're measuring the space filled by a liquid, gas, or solid. When you're measuring weight, you're measuring the actual heaviness of a substance. So when you're measuring volume, you could use the nested measuring tool. Make sure that it is flat, sitting on a flat surface, and you are measuring the ingredient into that until it reaches the line. Um, or you can overfill the measure and scrape away the excess, but do not pack the ingredient down unless it is specified. Now, if you are using a portioned scoop, make sure to fill that scoop completely and then level off to ensure consistency. Now that's volume. So going back to weight, the heaviness of a substance, you're going to use a scale to do this. So just make sure that the scale is sitting on a flat surface. You're going to turn the scale on, ensure that it does read 0. If you're going to add a container to the scale, make sure you add the container and then use the tare button. That will take the reading back to 0, and then you can go ahead and use the scale accordingly. So there's 3 different types I'm going to cover: digital, balance beam, and spring loaded. Spring loaded also might be known as a weighing scale, a mechanical scale, analog scale. This is definitely the most accurate way to measure any ingredient. I love recipes that are all in weights. It just makes converting that much easier, and we will get more familiar with that next week. But just know that scales are our best friends. So there's these 3 different scales I want to go over. I found some quick little videos, so let's let the videos do the talking.
Hi, I'm Zoe Francois from Zoe Bakes, and welcome to my kitchen. Today on Tips and Techniques, I'm going to be talking about my absolute favorite kitchen tool. Okay, it's hard to say that my favorite because I have quite a few of them, but this I feel like is super, super essential, especially for bakers: the kitchen scale. I love it. I think it makes your baking better because it makes it more consistent. I find it's easier to use. It makes less cleanup than using measuring cups and measuring spoons. I love, love, love it. I use this one. It's called My Way. I will link to it below. Super, super easy to use. But if you've never used one before, there are some tips. So one, turn it on. We're starting with the basics. Okay, I'm also doing this backwards and upside down. So when you're doing it, it'll be much more intuitive than this. So your scale will read 0, and then you want to have a bowl. Your recipe will usually tell you small bowl, medium bowl, large bowl. Follow whatever they say. And then what you need to do is hit this button right here. It's called the tare button. And what that does is it zeroes out the scale. Does it? What's going on here? There we go. So hitting the tare button will zero out the scale. So now I have the bowl on there, but it doesn't weigh anything because I tared it. And so I'm going to measure out 120 grams of flour. I use grams instead of ounces because I have an international following, and just about the entire world uses grams to bake with. And so I do all of my recipe developing in grams. Okay, so I need 120 grams of flour. So if I go over, I'll just scoop a little bit out until I'm right there. And then, there we go, 120 grams. So that is it. I turn on my scale, I zero out the bowl, I add my ingredients and get it to the weight that I'm looking for. If I want to add a second ingredient to the same bowl, if the recipe says in the same bowl you can put your cocoa powder, let's say, I want to add it right to that same bowl so I'm not dirtying more bowls. So I'm just going to add a strainer to it because oftentimes cocoa powder is lumpy, and I don't want to add lumpy cocoa powder to my nice flour. So add your sifter to the bowl and then tare it again so that it reads 0. And then add your cocoa powder. I'm going to add 30 grams just to show you. So my sifter and bowl reads 0. And now I'm going to go until I get to 30 grams. I'm pretty close. Try to get it all in the bowl. There we go, 30 grams. And so that's it. Now I have the amount of cocoa powder that I want, and I'm just going to sift it, because look at that. See how lumpy it is? I don't want those lumps in my flour. But that's how much cocoa I want. So that's it. You just turn on your scale, add your flour, tare it, and then add your next ingredient. It's as easy as that. I'm dirtying less things. It's simple, it's accurate, it's awesome. Use a scale. You're gonna love it, I promise.
So the only thing she didn't really go over, she did mention how she is using grams because she has an international following, which makes sense. We're going to get to the metrics in a bit. But I just wanted to point out where you could change the unit of measure. So on her scale, it actually said unit on the button, but right here you can just see above it says gram or G/OZ, which means grams or ounces. So on this scale, you can convert between the two. Usually, if you select ounces, it will eventually show pounds. And then other parts, important parts of the scale, obviously the on-off button. Sometimes this is also the tare button. So turning on or off usually requires you to hold down the button a little bit longer. And then tare is just a single click, and that's what's going to zero out your reading. The weighing platform is just wherever you are able to place the product to be weighed. And just remember that scales, to give the most accurate reading, need to be sitting on a flat surface. And note that scales do have a weighing capacity. So if you're weighing something and there's ever a bunch of E's right here, that looks like the scale is kind of like screaming, going, ee, you have hit the capacity, and you need to remove the product. Try to be conscious of the weighing capacity before you start weighing, because it's really hard to keep track of where you were, what amount exceeded the capacity of the scale. So it's usually listed on the bottom of the scale, or if there's an information sticker included on the scale, it will give you the weighing capacity pretty clearly. So these are the most common scales we have around the school too. So you'll see some that look like this or look a little different, but more or less they all operate the same. So next, we'll watch this video on a balance beam scale.
Hi, this is Chef Ellis, and we're at the Center for Culinary Arts here in Sarasota. Today we're going to be doing a brief demonstration on how to properly use a balance beam scale. It's one of the most utilized equipment in the bakery. Okay, so we have a balance beam scale. Some of the other equipment we have is the container that the flour is going to go in. Could be a bowl, could be whatever you would like, but this is the most popular so that we can get it into the mixer without getting the flour everywhere. We have a scoop for the flour. We have a counterweight. We have the 1 pound weight because we will be scaling 1 pound of flour. The first thing you need to do is you need to place the container onto the balance beam scale. The whole idea of the balance beam is to make sure everything is in balance. So we use the counterweight to make a return to that even balance, or to zero. It's the same thing if you were to press on an electronic scale. You have to press the tare or the zero button in order to get it back to zero before you start scaling. Now that it's evened out, we're going to add our 1 pound weight to the counterweight side. Okay, which means once we add a pound of flour into this side, it'll even out, and that'll tell us that we have exactly 1 pound. Okay, so now you see it went all the way over to the other side, which means it's just over 1 pound. So we'll take a little bit out until it gets back to the center. And that's how you get 1 pound. This is how you properly use the balance beam scale. Check us out for our other videos.
So pretty easy there. Again, bowl, counterweight, you are matching the weights. So you do need to have these available. They usually do come with the scale as well. Multiples allow you to stack and adjust the weight as needed. So that is a balance beam scale. And last but not least, these are the weighing scales, aka analog, spring loaded. There's a few different names, but if they look like this, kind of like the ones you see in the grocery store, they all operate about the same. So let's watch this video real fast.
How to use weighing scales. Firstly, you're going to need to place your empty container onto the top of your weighing scales. Once that's done, the next thing you'll need to do is set the scales back to zero. Slowly turn the wheel so the hand points to zero, and you're now set to start weighing. Place your ingredients individually into the container until the hand points to the correct weight. Do this for all of your ingredients to make sure that what you're making is perfectly delicious.
So pretty straightforward. What you can't really see is that dial she was talking about adjusting to zero. So here it is a little bit more clearly. So again, the bowl, a bowl holder is attached to the weighing platform. The adjustment knob, you can actually turn it, and that is what adjusts the face here. So whenever you are tearing out these scales, you're actually manually doing it using the adjustment knob, and then the center arrow should face zero here. So other measuring equipment that we have readily available in the industry, we have ladles. Ladles help us measure liquid and fluid ounces, and you can find the size of the ladle on the handle. Portion scoops. These are to regulate portion sizes of finished products and not used to measure ingredients. So these look like ice cream scoops. They usually have colored handles, and you can see the scoop number on the like release part of the scoop, and that number actually corresponds to the amount of scoops needed to make 1 quart. So very interesting. And then finally, we do also use count or each, and this is just to literally give the number of individual items. And also in the industry, but maybe a little bit further removed, we don't see this as much anymore, or you see this in larger formats, pecks and bushels. So that is what is pictured here. Actually, a peck is 2 gallons, so it's smaller than this, but this is actually a bushel. This is 4 pecks, meaning if there's 4 pecks in 1 bushel and each peck is 2 gallons, we are looking about 8 gallons of product right here. But this is often used for produce, so that's where you're going to find that unit of measure most commonly found. So these are our common food service measures and their abbreviations. Teaspoon is TSP, tablespoon is TBSP. C is just marked as a, cup is marked as a lowercase c. Pint is marked as PT. Quart is labeled QT, and gallon, sometimes it is written as a capital G, but I prefer to use gal just because lowercase g is what is used to signify grams. So sometimes that's a little hard to distinguish by, so I like to include the full acronym of gal. On the other side, we have fluid ounce marked as FLOZ, and our normal ounce is just OZ. Pound, definitely in the industry, you will see the pound sign actually used more often than LB or LBS. This one is interchangeable to me though, but I will be using the pound sign from here on out. Each is represented as EA. Case should actually be CS. I think that's just a little typo, so sorry about that. So that is CS for case. Bunch is usually signified by BU, and then to taste is a double T, TT. And these are our volume equivalents. I'm going to be handing out some more visual uh, worksheets that have these as well. And this is kind of like a good cheat sheet to have to memorize before we move on further, because this is the basics of converting. We need to know how to convert between these units of measurements. So just know that every 3 teaspoons makes a tablespoon. Every 4 tablespoons makes a quarter cup, which then means there is 16 tablespoons in 1 cup. Every 2 cups makes a pint. Every 2 pints makes a quart, meaning that there's 4 cups in a quart. And every 4 quarts makes a gallon. So it's kind of that gradual step up. So there's all the visuals here, and then you could go back and even count how many cups, or between these jumps you can kind of figure out how many cups are in a gallon. Also good to know, when measuring liquids, a tablespoon is about a half fluid ounce. And also measuring liquids, 1 cup is 8 fluid ounces, 1 pint is 16 fluid ounces, 1 quart is 32 fluid ounces, and 1 gallon is 128 fluid ounces. So keep that in mind, the difference between ounce and fluid ounces. We're going to get back to that in a bit. Just another visual too, just to have a different format. So again, this is all of the smaller units of measure that make up a gallon, and it does include a little metric conversion here as well. So this is a pretty good conversion cheat sheet. So 1 quart again is made up of 2 pints, but it's also 4 cups. It is also 32 fluid ounces and 950 milliliters. So 1 quart is almost a liter, just very close. 1 pint is also 2 cups, meaning it's also 16 ounces and 480 milliliters. 1 cup is 16 tablespoons, also known as 8 fluid ounces and 240 milliliters. 1 ounce is 2 tablespoons, because remember, 1 tablespoon is half an ounce, so 2 of them together make 1 ounce, or 30 milliliters. 1 tablespoon is, as we learned, 3 teaspoons. It is also half an ounce and 15 milliliters. And our very, very smallest measurement down here, 1 teaspoon is 5 milliliters. And one last visual for us, just know 128 fluid ounces in a gallon, 16 cups in a gallon, 8 pints in a gallon, 4 quarts in a gallon. So if you can memorize these, it's easy to get between the different steps and converting between these units of measure. So the misconception I was talking about earlier, the misconception, if you didn't get that. So what is wrong to assume is that 1 cup is 8 ounces of any ingredient. What we talk about when we say confidently 1 cup is 8 ounces, it's actually 1 cup is equal to 8 fluid ounces of water or water-like liquids. So remember that ounces is measuring weight, but fluid ounces is measuring volume. So, are they interchangeable? Fluid ounces and ounces are only the same if the measured ingredient has the same density as water. So, for example, 1 cup of juice we could assume is more or less about 8 ounces. Now, if it had a lot of pulp in it, it's probably going to change the weight of it. It's going to be a little heavier than water. But assuming it's a strained juice, it's probably going to be about 8 ounces. That's a safe assumption to make. Now, some liquids are actually lighter than water, but it's so close that we do just generally like ignore it in the culinary world. And the best example I can give you is 1 cup of oil. If you were to weigh that out, actually, it would be about 7 3/4 ounce. But that 0.25 ounce, we kind of just, round up, say it's close enough, good enough. We treat it as an 8 ounce. Now, heavier liquids are not interchangeable. Now, think of honey. Honey is rich, it's thick. When you pour it out into a 1 cup, it would not weigh 8 ounces. It actually weighs more about 12 ounces. So, when you're looking at something that is measured in that cup, the nested cup, just imagine, is it close to water? Does it have the same viscosity, same density? If it does, you can more or less treat it as that fluid ounce weight. But if it's not, if it's severely different, and especially if it's a dry ingredient, it will not weigh the same as 1 cup of water would. So we will practice this in real time so you can actually see the difference between the weights of 1 cups of different products. Moving on. So the metric system, we learned a little bit about it in that first scale video. It is the mathematics system used throughout most of the world. It is a decimal system based off the multiples of 10. So there's just 3 basic units, and then all of these prefixes here are attached to a certain number, and that is what is going to actually dictate the size of those basic units. So grams is how they are weighing things, liters is measuring volume, and meters is measuring length. So we should already be familiar with some of these terms, like grams, is definitely more common in baking, but in the culinary world, I'm sure you've come across it already. Liters, a liter of soda, we do sell things like that. It is a common unit that we have out in the wild that we can purchase. And of course, meters, centimeter is what we are most familiar with, being on the ruler. And in culinary, we do have a couple of these terms. Kilo is definitely most common, and milli. So we really don't go beyond a kilo or milli. So we stay within this range here. But those are the most common units of measure you're going to see in the culinary world with the metric system. So again, we will see grams and kilograms. This is their short acronym. Liter is marked with a capital L, and then this little m is milliliter. Centimeter, so again, small c, small m to measure length, and then capital C actually measures temperature, and this is Celsius. This is in comparison to our US standard or the imperial system used in the United Kingdom. In US standard, we see ounces, pounds, teaspoon, tablespoon, fluid ounces, cups, pints, quarts, gallons. And what makes imperial just slightly different is the use of stones, which is actually a 14-pound unit of measure. So very interesting. I've never used them myself, I've often heard stones used to measure body weight, and I'm not sure how often it's brought into the culinary world, if at all. So, advantages of using the metric system is that it is an internationally recognized system. Most countries than not use it. It is just easier calculating using the metric system because it's based off the number 10, so everything is multiples of 10. And this is a unit of measure that is easier and more accurate for very, very small portions. So if you had to do, especially with molecular gastronomy, you're using food additives, you need to be working with grams because the difference between grams and ounces is huge. And if you need things to be exact and precise, grams is going to be your best friend. So here are some of our metric equivalents. We already saw this before, but 1 teaspoon is 5 milliliters. 1 fluid ounce is 29.6 milliliters. 1 cup is 236.6 milliliters. 1 liter is 1,000 milliliters. See how easy that was? And 1 liter is also equal to 33.8 fluid ounces. So just over a quart, because 1 quart is 32 ounces and 1 liter is about 1.8 more fluid ounces. Weight, 1 gram is 1,000 milligrams. 1 kilogram is 1,000 grams. 1 ounce is about 28.35 grams, and 1 kilogram is about 2.21 pounds. So we could use these equivalencies to help us convert between the metric system and our US standard system. So we will practice that a little bit more on our assignment this week. So when we are converting between units of measure, um, sometimes we need to do this when we're working within our own US standard weight and volume measures. So for example, if you needed to convert something from pounds down to ounces, or gallons down to cups. You can also do this within the metric weight and volume measures, so converting between liters to milliliters or grams to kilograms. We can also do this between the metric and US standard systems. So if you had a recipe that was in grams, but you wanted it in ounces, you could easily do that. Or vice versa, you have something in fluid ounces and you want to change to liters, no problem. We also can do this between weight and volume. So if something was measured by the pound, but we need it in quarts or grams into teaspoons, but we'll talk about some issues that we'll run into with that. There's a lot of estimating, but there are some charts. There has research been done, so we can find the resources online to help us when we need to convert between weight and volume. So to do this, we do need to know our equivalencies. We need to know the measure, the unit of measure that we're working with, and then how much of another unit of measure it will take for it to be equivalent, to be balanced on both sides of that equal sign. So we've already kind of gone over some of those before, so feel free to refer back to those charts. And then I will also give you guys some handouts that should be helpful and really, really useful to put to memory as well. But it's good to have the visuals and practice looking at those charts until you get familiar and it does become like second nature to you. So let's learn 2 different methods. We're going to go over the bridge method, aka dimensional analysis. I know that sounds complicated, but it's really not. It is the more long way to do this, but it just shows you every single step. And then the advanced conversion method is when you get really familiar with those equivalencies that I just mentioned, and then you'll be able to kind of skip over the middle step in the bridge method and just kind of get more straight to the point. But let's take it slow and let's learn about the bridge method, aka dimensional analysis first. So I'm going to let the video do the talking.
Learn unit conversion the easy way. The method that we will be using to convert between units is known as dimensional analysis, or the factor label method, or even the unit factor method. But what we call it really doesn't matter. What matters is the fact that this is a versatile and powerful problem-solving technique. So let's just do this. We're going to start with a simple unit conversion problem. A weightlifter can lift 495 pounds. How many kilograms is that? In order to solve a unit conversion problem like this, we first need one more piece of information, the conversion factor. For pounds and kilograms, the conversion factor is 1 kilogram equals 2.2 pounds. Now we're ready to solve this. The first thing you should always do is write down the quantity that you want to convert. This is the number from the question, not the conversion factor. Please also include the units. Next, we're going to multiply this number by a fraction. Inside the fraction, we're going to write the two numbers from the conversion factor. But how do we know which one goes on top and which one goes on the bottom? To answer that question, all we need to do is look at the units, which is why we always include the units in the calculation itself. The quantity we are starting out with has the units of pounds, so we take 2.2 pounds from the conversion factor and write it on the bottom. Next, because we want to end up with kilograms, we take 1 kilogram from the conversion factor and write it on the top of the fraction. Notice that the pounds that we started out with cancel out with the pounds on the bottom, and the units that we have left on the top are kilograms, which is exactly what we want to convert to. The only thing left to do now is plug the numbers in our calculator. You could, of course, put this in your calculator exactly the way it appears here. But maybe you don't have one of those fancy calculators that can do fractions, or maybe like me, you just want to find a shortcut. Because the number on the top of the fraction is 1, this becomes a simple division problem. In your calculator, type 495 divided by 2.2, and your calculator should tell you the answer is 225. Our final answer, therefore, is 225 kilograms. There is one more thing that we should notice about this problem. The fraction 1 kilogram over 2.2 pounds actually equals 1, because 1 kilogram equals 2.2 pounds. In fact, anytime we do unit conversion, we are simply multiplying our initial quantity by a conversion factor fraction that equals 1. Okay, now that we are experts at this technique, let's try a slightly harder problem. A certain car has a mass of 1,920 kilograms. How many tons is that? Just like always, we need the conversion factor before we can solve this, but this time we need two conversion factors. One to convert from kilograms to pounds, and another to convert from pounds to tons. So this is going to be a two-step problem. We start the problem by writing down the quantity from the question, 1,920 kilograms. And then we multiply this by a fraction. The two numbers that go in the fraction come from one of the conversion factors. But what goes on the bottom? Because we are starting with kilograms, we write 1 kilogram on the bottom of the fraction so that we can cancel out the kilograms. Next, the other half of that same conversion factor, 2.2 pounds, has to go on the top. The kilograms cancel out, leaving us with pounds as the units of our answer. When you do the math in your calculator, simply multiply 1,920 by 2.2. This time we are multiplying the numbers because the 1 of the conversion factor is on the bottom of the fraction. Our calculator tells us that the answer is 4,224 pounds. But we're not done yet. We still need to convert the pounds to tons. The second step works exactly the same way. First, we write down the number that we want to convert, that is, 4,224 pounds, and then we multiply this by a fraction. We want to have pounds in the denominator of the fraction so that we can cancel out the pounds. But which pounds do we choose? 2.2 pounds or 2,000 pounds? Remember that we want to convert to tons, so we choose the conversion factor between pounds and tons. We write 2,000 pounds on the bottom and 1 ton on the top. Our pounds cancel out, and we are left with tons for the units of our answer. In our calculator, we type 4,224 divided by 2,000, because the 1 is on the numerator of the fraction. Our final answer works out to be 2.11 tons. Okay. We got the correct answer, but it turns out that there is an even better way to solve problems that involve multiple conversion factors. Rather than solving this in two separate steps, we can combine those steps into one step with two conversion factors. Check this out. Once again, start the problem by writing down the quantity that you want to convert. Multiply this by conversion factor fraction, putting what you want to cancel out on the bottom and what you want to convert it to on the top. Notice that so far this is exactly the same as the first step we just did. However, instead of solving this as it is, we're going to multiply it by another conversion factor fraction. We now need to cancel out the pounds that are left on top, so we put 2,000 pounds on the bottom. We chose 2,000 pounds rather than the 2.2 pounds because we ultimately want to convert the quantity to tons. This gives us tons as our remaining units on top, while all the other units cancel out. We then proceed to calculate from left to right. If the 1 is on the bottom, we multiply. If the 1 is on the top, we divide. So, we multiply 1,920 by 2.2 and then divide that answer by 2,000. Final answer is 2.11 tons, which is exactly what we got the first time. But now we can see how powerful this method is. No matter how many conversions you need to do, putting the conversion factors in fraction form helps you to know when to multiply or divide. Thanks for watching. Please comment, vote, subscribe, or check me out on ketsbook.com.
So hopefully that was helpful as we start to learn this. So again, this is the steps to do that that whole process. So you are going to one, read the question, or figure out whatever you need to do. So our example here says express 10 quarts as gallons. We are going to write that measurement and convert it into a fraction. We're just going to simply write 10 quarts and place that over a fraction line followed by a 1. So anything divided by 1 is equal to itself. So this is still the same as 10 quarts. It's just 10 quarts expressed as a fraction. And we are going to multiply that by the equivalency. We're going to write what we are converting to, which is gallons. So 1 gallon goes on top. The equivalent of gallons in quarts is 4. There's 4 quarts that make a gallon. So we're placing the common unit of measure on the bottom. So like he said, we can now cancel out quarts on top and on bottom, leaving us with 10 gallons divided by 4. Plugging that into my calculator, I got 2.5 gallons. So that's the whole process. It's a little long to write out, but really not that bad. And this helps us practice memorizing our equivalencies. So again, this is where we start. The question gave us this information. It tells us where to end up. So that is our unit of measure on top always, because this will not be canceled out. The equivalent in that matches a unit of measure in the original number is put on bottom. So those get canceled out. And that leaves us 10 divided by 4, and 10 quarts is the same as 2.5 gallons. The advanced version, he kind of showed very quickly at the end. It's just essentially skipping over that middle part. So let's see, convert 66 ounces into pounds. I'm going to set up my equivalent fraction. So again, we're starting with 66. I'm going to just place that over 1. So it's a fraction, and we can see our method working out. We're converting into pounds. So on this round, I'm going to write 1 pound on top. And 16 ounces makes a pound. The ounces on bottom here cancel out the ounces on top over here. So I'm left with 66 divided by 16, which gives me 4.125 pounds. And as you can see, the advanced method down here, it just allows me to essentially merge these two fractions together without actually writing it out in the middle. So once you get more familiar with the equivalents, you can just take the unit of measure and the amount of it that they start with and divide by the equivalency to whatever unit you're trying to convert into. And that way, it's just a little faster. So you will get there with time and practice. So don't be afraid to just start here, writing it all out. Like I said, it's a good way to start memorizing these equivalencies. And then with enough practice, you'll be doing this in no time, just maybe not even having to write out the fraction, just plugging it straight into a calculator and going from there. So we're going to practice both of these methods more in class and on your assignments. So changing between common units, this may feel a little backwards at first, but if you actually think about it, and once we start visualizing what's happening, this will become more like second nature to you. So, but up front, we might have to just sit and think about it a little bit longer. So just know that when you're going from a larger unit of measure, so like pounds down to ounces, you're expanding out from that larger unit. So there's 16 ounces in every pound, but if you need to go from pound down to ounces, you're going to have a lot of ounces. Remember, you're trying to you were grouping all of those ounces into the pounds. So each pound represents 16 ounces. So then when you go from pounds to ounces, you're actually expanding. So when you go from a larger unit down to a smaller unit in expression, not in numbers, you're multiplying. So pounds to ounces, multiply by 16 because there's 16 ounces in every pound. If you're going down from cups to fluid ounces, you're going to multiply by 8 because there's 8 ounces in each of those cups. If you go from quarts to fluid ounces, you're going to multiply by 32 because every quart represents 32 ounces. And then gallons to quarts, you'll multiply by 4 because every gallon is made up of 4 quarts. So you're expanding in expression. So just the opposite on the other side, if you're starting with a smaller unit, but you want to express it in a larger unit of measure, you're going to divide. You're going to start grouping those units of measure together to represent them in a larger format. So if you go from ounces up to pounds, you're actually dividing by 16 because you're going to start grouping those 16 ounces together. And every time you do that, you're getting 1 pound. Same thing, fluid ounces to cups, divide by 8. Fluid ounces to quarts, divide by 32 because there's 32 ounces in a quart. And if you go from quarts to gallons, you're dividing by 4. And these are just some examples. There are different units of measures to convert to. So again, once you get familiar with the equivalencies, dividing or multiplying, if you're going from larger to smaller or smaller to bigger, is going to become easier with that equivalency knowledge. When we are converting with mixed measures, we do this because it does help us in preparing, costing, and ordering ingredients. This does save time by measuring faster, and it does help reduce the chance of error. But knowing the difference between weight and volume equivalence is necessary to do so. There is always more than one way to convert, and sometimes estimations are necessary when recipes measure dry ingredients using volume units. So this is definitely what we're going to find in our home cook recipes. You're going to see things like 1 cup chopped scallion, which is kind of subjective. It doesn't specify like how chopped. Is it a fine chop, a rough chop? Did that individual pack down their ingredients and you don't? So that's why those nesting measuring cups especially are suspect for inconsistencies because it's by volume, and volume with a dry ingredient is subjective to how the ingredient is prepared, the state of the ingredient. Is it raw? Is it cooked? Or the individual weighing it too, and the method that they choose to weigh. So sometimes though we do convert between weight and volume and weight, just depending on the recipe and the circumstances. So some equivalent tables exists already, and we can use Google to help us find them, or even just um, taking the AI suggestions as well, the first thing that pops up on your Google search, more or less to have an average amount, but doing a little investigating or maybe even weighing these ingredients out yourself will help you understand the difference between the two. But nonetheless, we still use the bridge or advanced methods to solve. So let's see one of these. So, for example, a recipe requires 24 ounces of fresh blueberries, and fresh blueberries are sold in 1 pint containers. How many pints of blueberries should be ordered? And our hint here says that 1 cup of blueberry weighs 7 ounces. So it's not 8 ounces, it's 7. So our good example here of volume versus weight. 1 cup of blueberries is not 8 ounces, it's actually 7. So I'm going to use the bridge method here to break this down. So I'm going to write the original measurement as a fraction first. We need 24 ounces of blueberries. Just throw that over a fraction line and 1. And next to it, I need to identify the equivalence between the original measurement and desired measurement. I'm going to write those as fractions with the original measurement unit in the denominator, meaning in the bottom. So again, our hint told us that 1 cup of blueberries weighs 7 ounces. And from our knowledge now, we know that every pint has 2 cups. So I'm going to need both of these because we're going from ounces to pints to cups. So there's all these different units of measurement. So let's set up our calculation. I'm going to set up the calculation to make sure that the common units of measure cancel each other out, meaning they have to be opposite of each other. So I'm starting with 24 ounces, and I know that 1 cup is 7 ounces. So 7 ounces here and ounces on top over here. Cancel those ounces out. I'm left with the 1 cup measurement on top and the 2 cup measurement on bottom. So that's going next to each other to, again, cancel those units out. So in the end, I am left with 24 over 1 multiplied by 1 over 7, because those units of measure were canceled out, multiplied by 1 pint over 2. And then just following that across, I get 24 pints divided by 14. Following that math through, I am left with, I need 1.7 pints. However, this is where some of our culinary and cook knowledge is going to come into play. I know that I can't buy 1.7 pints of blueberries. Buying that zero point 0.7 pint is not an option. So I can only buy a full pint. So that means I need to purchase at least 2 pints to have enough. So this is where that rounding, some judgment is going to come into play to answer these questions accurately. So, like we just saw, there are some rounding realities, as I'm going to call it. When we're working with decimals, don't round too early. So, leave the full expression in your calculator when possible, especially if you have a running decimal, if it's just 1.77777 for the ever until the end of time. Try to leave that in your calculator as its full expression. Or if you're needing to write these things down on paper or you want to just simplify it for yourself, keep at least 4 decimal spots. So that means the whole number, the period, the point, and then 4 more numbers after that decimal spot. You won't want to round decimals until the final answer is reached, and then you can analyze and also make sure, especially when you're solving word problems, you're answering the word problem correctly. It might tell you round to the nearest tenth, round to the nearest hundredth, choose the next whole number, or round down to the next whole number. So pay attention to what the question is asking you as well. When you're ordering, though, usually you're rounding up. So just like in our example with the blueberries, I can't get a 1.7 pint. I have to purchase 2 full pints to have the 1.7 pints for my recipe. So consider the ingredient and how it's ordered. Can you break a case? Can you not break a case? You're usually just rounding up to the next whole number to ensure that you have enough product. And estimate when appropriate. Again, consider the ingredient and decide how precise the measurement needs to be. So if you, at the end of converting a recipe, which we're going to get into in a little bit, you see something that says 1 cup plus 3 tablespoons of salt, instead of having those mixed units of measure, instead of having to grab the 1 cup and the tablespoon, you could just say, hey, this probably needs, that 1 extra tablespoon of salt anyways. So let's round up to a 1 1/4 cup salt. So then you could only have to use the measuring cups and not measuring cups and spoons. Or, for example, 33 ounces of water versus just 1 quart. Do you really need that extra ounce? Maybe not. Then you could just round down and go with that solid quart measurement and not have to worry about that extra ounce. This does come easier with practice and the more familiar you are with the ingredients. So don't feel too bad if it kind of doesn't make sense up front. You'll start to get more familiar with it, especially the longer you are in the industry. Well, it looks like that's it actually. So, yeah, we have lots of practice to do in class. Hopefully, you are able to review this before Wednesday. If not, that's okay. It is our first week, but from here on out, do try to review these video lectures before class on Wednesday. just so we can make the most of our time together and practice with more visual activities, doing math on the board together, being able to ask questions, and just being more hands-on. So lecture is always going to be online through these videos. The PowerPoint without the narration is also available if you wanted to go back a little bit more slowly, take notes at your own pace. I highly encourage that. Otherwise, you made it. Thank you so much for sticking with me till the very end of the video. And I know that this is maybe easy to start with, but the foundation in culinary math, learning the basics, and especially our units of measurement and all of the equivalencies is what is key to making culinary math easier the harder and more complex we get into it. So don't take this for granted. We are definitely going to move on next week into converting recipes. And yeah, we're going to have a great class together, guys. So thank you so much. I look forward to seeing you guys in class. Bye.